Alright, so here we found the numbers for the missing columns, and what we need to do here in lesson 3 is to identify the rule. So in part 1, okay, we can see that if we took 3 to get 9, we took 3 times 3. And 11 times 11 is 121. So 2 times 2 is 4. What number times itself is 81? That would be 9. Okay, so we found that these were perfect squares and how to do that. So our rule would be, I found the column on the right by squaring the numbers in the left column. So 13 squared is 169. So m would be m squared. I found the left column by square rooting the numbers on the right side. So the square root of 49 is 7. The square root of n is the square root of n. That's how that would be written. Over here in part 2, to find the rule, okay, we said, okay, so 3 times 3 times 3 is 27. 6 times 6 times 6 is 216. So we're multiplying this number by itself twice. So 2 times 2 is 4, times 2 is 8. What number times itself is 125? So that would be 5. So down here for the rule, to find the right column, I cubed the numbers in the left column. And to find the left column, I cube rooted the numbers in the right. So for p, it would be p to the third. And for q, it would be the cube root of q. Okay, and we're going to look into these some more, and I will provide you with a link below the video of the first so many cube roots in just a second. So the properties, we're going to be looking at rational numbers as we move on. And rational numbers are just numbers that have a terminating decimal or terminating number. So like the square root of 100 is 10, or 1/4 is 0.25. Numbers that terminate or have a repeating pattern like 0.12, 12, 12, 12, those are called rational numbers. So we're going to be looking at those in this lesson. So in the past, we've determined the missing length of a right triangle x when x squared equals 25. So we know that x squared equals 25. If x squared equals 25, like this, okay, we know that x would be 5. 5 times 5 is 25. Okay, if we did not know that we're trying to find the length of a side of a triangle, the answer could also be -5, because -5 times -5 is positive 25. Okay, however, because we're trying to determine the length of a side, we provide a positive length. A length cannot be negative. Now that we know that positive square roots exist and are unique, okay, we can begin solving equations that require roots. So for example, we have this. So to solve this equation, because this is an actual equation, we do what we do for all properties of equality, which that just means we do the same thing to both sides of the equation. So we assume that the square root is positive, so what we would do is we would take this equation right here and we would square root both sides. So the square root and the square cancel each other out, so we're left with x equals, and the square root of 25 is 5. Okay? So that's how we would work this out. And the first step would be to square root both sides. Okay? And we're going to do that with the square root symbol just like we did. And this symbol, if we have this symbol to something here, the symbol just means it's a radical. We call that a radical. And then this is referred to as a radical equation. So far we've only worked with square roots, which would be this, but we write it like this, okay? So we're going to go beyond that.
Miss Greenlee?
Yes?
You have a parent pal gift in the office.
Okay, thank you. Ignore that interruption. So when x equals 3 for this problem, we would write it as the cube root, just like this. So it would, what that means is it wants to know what number times itself equals the number inside. Okay, so that would mean so if we put y, if we put 27, the cube root of 27, what number times itself equals 27? So 3 times 3 times 3. So the answer would be 3. Okay, so now we're going to go and work this equation. For what value of x is the equation x to the third equal 8 true? So because this is to the third, what we're going to have to do is we're going to have to cube root it. So I'm going to cube root the left and I'm going to cube root the right. So the cubes cancel each other out, so we're left with x equals, and this is just asking what number times itself, 3 numbers, what number times itself equals 8. 2 times 2 times 2, 2 times 2 is 4, times 2 is 8, so x equals 2. Okay? We're going to stick with square roots and cube roots for what we're doing. Okay, we're not going to go beyond that. So we're going to go jump in here to the next page. We're going to go through these here, 1 through 6 real quick. So x to the second equals 169. Because this is to the second, the first step would be to square root both sides of the equation. So if I were to do this, I would have x squared equals 169. Okay, so that I would write out the equation and then I would square root both sides. The square root and the square cancel each other out, so I get x equals, and this is asking what number times itself is 169. So the number times itself that is 169 is 13. Okay. A square-shaped park has an area of 324 yards. What are the dimensions of the park? Okay, so we have a square. The area is 324. We know that a square area is found by the side times the side, and the sides are the same because it's a square. So this times this would be x squared equals 324. Okay, so this would be our equation. Because there are two x's here, it's x squared because we're multiplying them. So to do this, the first step would be to square root both sides of the equation. So I'm going to square root the left and square root the right. So the square root and the square cancel each other out. So x equals 18. So the length and width of the park are 18 yards. Okay, because that's what x is. Here we already have our equation on number 3. It's a square. X is squared, so we're going to square root both sides. So I get x equals, the square root of 625 is asking what number times itself is 625, and the answer is 25. Okay, and you can always check yourself by saying what is 25 squared equals, and that is 625. Same thing up here, you can check yourself by saying 13 squared is 169. Okay, a cube has a volume of 23 inches cubed. So I have this, okay, the whole volume, this is a cube, the whole volume is 27, and because it's a cube, we know the left, or the right, the bottom, and the front are all the same. So we know this is x squared equals 27, or x cubed, sorry, because there's 3, it's cubed. So x cubed equals 27. Because this is cubed, we would cube root the right, or the left, and the right. The cubes are going to cancel each other out, so we get x equals, and this is asking what number times itself equals 27. And I know that 3 times 3 is 9, and 9 times 3 again is 27, so the answer would be 9. So the length of the side is 9, and our unit was inches. Okay. 5, what positive value of x makes the following equation true? Okay, so x squared equals 64. Okay, because this is squared, you're going to square root both sides. The square root and the square cancel each other out, and then we're asking what number times itself is 64, and we know that that is 8. 8 times 8 is 64. Okay, and the one thing that we have here is the explain. So you need to make sure that if it says explain, you do this. So to find x squared, I'm looking for a number times itself to equal 64, which is finding the square root of both sides. The square root of x squared is x, because x squared equals x times x. The square root of 64 is 8, because 8 times 8 is 64. Okay, again, we're going to do the same thing on 6 and explain. Okay, so we have x to the third equals 64. Okay, because this is a cube, x to the third is a cube, we're going to cube root it. So the cubes cancel each other out, so x equals, and then now we're looking for what number times itself is 64. So 4 times 4 is 16, 16 times 4 is 64. So the answer would be 16. And then to explain it, we would say to find x to the third, I'm looking for a number times itself 3 times to equal 64, which is finding the cube root. The cube root of x to the third is x because x to the third equals x times x times x. The cube root of 64 is 4, because 4 times 4 times 4 is 64. Okay? So x equals 4 here, and x equals 8 here. Now we're going to jump into identifying some roots of more interesting numbers, or maybe a little bit more difficulty level. So now we're going to throw in some fractions. And here's the deal with this. When we have a square root of a fraction, it's simply saying the square root of 1 over the square root of 4. So the square root of 1 is 1, the square root of 4 is 2. You just square root the top number and then you square root the bottom number, and that would be your answer. Same thing here, the square root of 1 over the square root of 81. The square root of 1 is 1, 1 times 1 is 1. The square root of 81 is 9, 9 times 9 is 81. That's how we would do this. Here, we're going to break this up the same way, except for instead of doing square root, we're going to do a cube root. So the cube root of 8 over the cube root of 27. So the cube root of 8, what number times itself times itself? So 3 would be 2. 2 times 2 is 4, times 2 is 8. What number times itself is 27. Okay, so 3 times 3 is 9, times 3 is 27. Okay, so that's how you would work fractions with square roots and cube roots. Okay. We're also going to look at, this would be 3, sorry, 2/3. 3 times 3 is 9, times 3 is 27. I don't know where I wrote 9. It would be 2/3. At equations like this, and in math, you guys have talked about negative exponents. So we should know how to change 25 to the negative 1 to a fraction. So this would be x squared equals 1 over 25. That's what the negative 1 does. It takes the 25 and puts it in the denominator. So now we're looking for what number times itself is 1 over 25. So we would square root both sides. So x equals, the square root of 1 is 1, the square root of 25 is 5. So x equals 1 over 5. So another way to write 25 to the negative 1 is 1 over 25. You guys have talked about that. And then another way to write this as x squared equals 1 over 25 would be x equals 1 over 5, because 1 over 5 times 1 over 5 equals 1 over 25. Okay? I want you to attempt to do 7 and 8. And then when you show me those, I will explain number 9 to you.